Hey folks, Derek McCarthy with NetRise here. In this short demo video, we are going to showcase some of the scalability of the NetRise platform, as well as a handful of other features that kind of go hand in hand with that scalability, and talk a little bit about the data-driven approach that we're taking to this problem space and some of the challenges that exist. For anybody not familiar, at a super high level, the NetRise platform is a fully automated binary analysis platform. You upload binaries into the system. We rip them apart, we analyze them, we generate a software bill of materials, correlate the software components that are identified to vulnerabilities, enrich that vulnerability data with tons of additional threat intelligence, exploit data, and context to help prioritize, as well as identifying all sorts of other risk that exists within these binaries that may not necessarily be tied to a known CVE. The purpose of this video is certainly not to go through all of the different platform features and use cases. Definitely feel free to check out our other demo videos for some highlights of that. But again, really the purpose of this video is to talk about that scalability. So from a scalability standpoint, just from a raw numbers standpoint, we have the ability to analyze upwards of 3,000 images concurrently per unique customer tenant or instance of the platform, right? So in a scenario where I were to upload 3,000 images all at the same time, whether that's through the UI, if you can click super fast, likely, very much more likely through the API, all of those images would get ingested into the platform, and they would analyze in parallel, right? They don't go into a queue. All of that analysis happens, concurrently. Another thing to mention is that we do support multi-tenancy in our platform, right? So you can use the same credentials to access multiple instances or multiple tenants within our platform, which, given that multi-tenancy, along with that 3,000 or so image benchmark, you essentially end up with unlimited scalability, right? And imagine a scenario where you had 10 tenants, you uploaded 3,000 images to each of those 10 tenants at the same time. You'd be analyzing 30,000 firmware images at once, right? So to showcase a little bit of that, what we're going to do is, as you can see, I have a totally blank, fresh instance of the platform here. No data has been loaded, no assets have been uploaded, no binaries have been uploaded into the platform. So I'm just going to go ahead and run a very simple API script to upload a bunch of firmware and other binaries, right? So for the purpose of this video or this demo, I'm going to upload somewhere between 70 and 80 images. But again, we really have essentially unlimited scalability. So I'm just going to run a very simple API script that should kick off in a moment here. And again, really what it's doing is just iterating through a folder that I've created that has a whole bunch of binaries in it. So we can see that running. I'll pull that off to the side. I'll jump back into our dashboard here. We can see some files have already started to extract, and if we jump into our assets table, we can see already 16 or so of these images have uploaded, and you can tell, all of these analyses are in progress. There is no queue. All of this analysis is happening at the same time. So we're going to let this run for a moment. I've uploaded a wide variety of things. As many folks probably know, in the firmware space, you see all sorts of different stuff, right? You see real-time operating systems and bare metal firmware and embedded Linux firmware images. So, some images may take longer to analyze than others, but we should have some results here just in a couple of moments. A number of these images that I've uploaded are real-time operating systems, which typically analyze very quickly, sometimes faster than just a minute or less. So we can see here more images have started to populate. Again, I think I uploaded something like 80 images. And we can see now back on the dashboard that we have some reports that have already been generated, which means that analysis is finished. So if I scroll down and look at towards the front page, or the latter pages, we have some of these that have completed, and obviously some of them are still running, right? We've been running for about 60 seconds or less here. So again, this just shows that these images are analyzing all in parallel, all at the same time. 16 of them have completed, and we'll see those numbers continue to grow, as the video goes on. So, as I mentioned towards the beginning, something we like to talk about is this data-driven approach that we're taking to, to this challenge, right? So, if we look at our overview page, or what we call our dashboard, we can show kind of one example of that, and then I'll dive into a bit more detail as well as more of this data starts to roll in. So, something that we can take a look at is prioritizing vulnerabilities across a large number of images, right? So again, so far we have results from 16, but we'll see these numbers start to increase as more analysis finishes. And for example, we already have upwards of 3,000 unique vulnerabilities that we've identified across all of these images. So what can we do to prioritize those? Well, there's all sorts of different ways, as everybody knows, to prioritize vulnerabilities, but a way that we think is super effective and valuable is to look at what is the true risk of the vulnerabilities based on, is there even an exploit that exists, right, for that particular CVE? So we can take a look at this vulnerabilities of interest table, which shows us, of the 3,000 or so vulnerabilities that we've identified, how many of them actually have exploits that exist? Are they being used in things like ransomware campaigns, or are they associated with botnets or known APT groups or threat actors? We can very easily click here as an example to say, show me these 6 unique vulnerabilities that exist across all of my binaries that are actively being used to drop ransomware payloads by threat actors. And that's going to show me the 6 vulnerabilities that fall under that category, the software component in which that vulnerability was found, the total number of occurrences of that particular CVE, and then most importantly, because we're on the dashboard, right, we haven't drilled into a specific report just yet, which assets or which binaries is that particular CVE found in. So as an example, we have the CVE 2019-6111. It's a vulnerability in OpenSSH. It's found one total time in one asset, and I can click here, and actually we can see that the data has started to kind of surpass the dashboard. So if I just refresh the page really quick, we now see that we have 31 complete reports. We can go look at the same vulnerability, and we see that it's actually found in 2 assets, right? The data is just kind of surpassing our dashboard here for a moment. So I can click there and see that, hey, here are the 2 images, right, where that particular vulnerability is found. And we can dive into one of these reports, which we'll do in a moment, to talk about one other piece from a scalability standpoint. Another way that you can prioritize, again, I think using this exploit data is a great way. Something that goes hand in hand with that is looking at something like the CISA known exploited vulnerabilities, right? So for example, across the 31 images that we've now analyzed and generated reports from, again, we can see more images rolling in and continuing to analyze. Across these 3,000 vulnerabilities, 9 of them are present in the CISA known exploited vulnerabilities, or the CISA KEV catalog. So I can do the same thing, right? I can click here, and it's going to show me all of the 9, in which case now we're already up to 11 unique CVEs that exist in the CISA KEV. Which component it's found in. We're surfacing the due date as well for those vulnerabilities being patched by the manufacturer, and again, showing you which assets are those particular vulnerabilities found in, right? And we can see here, and again, we can dive into those individual reports from there. So before we dive into a report and touch on the last piece, I just want to refresh this page. Again, we can see more images continuing to come in. We've uploaded a total of 68 binaries now at this point, and just going through, we can see some of these still analyzing the ones that we've uploaded recently. And if we kind of keep going through the pages, we can see many of these results have already finished and have already generated reports. So again, it really just gives you an idea of that scalability that we're able to achieve. It's been maybe 5 or 6 minutes in the demo video, and we've already generated results from dozens of images that we've analyzed. So, the last piece that I want to talk about is just going into, we can pick really any of these reports, dive into the details a little bit, And again, the purpose of this video is not to talk about all the different features and use cases that we have. But if we jump into vulnerabilities, typically we can find a good example of what I want to show here. So, and here happens to be one. So something that we do for every data point that we have in the platform is, often as a, either an asset owner or a manufacturer of a device, when you identify some risk, right, whether that is a CVE or it could be a device misconfiguration or a weak binary or maybe a public key or a private key or a set of credentials that might be weak or default, one of the things you are likely going to ask yourself is, we found it for this one device, right? But where else in my environment does that risk exist? And again, to highlight that data-driven approach that we're taking to the data that we have, we do that correlation automatically for you in real time, right? So we can see here's a great example of a particular CVE that's found in this expat library. And, we found it for this image, right, that we've uploaded into the platform. But, let's say this is some very critical new finding, and we want to know really immediately, like, where else is this thing found? Again, whether that's a CVE or a private key or a set of credentials, it doesn't matter what it is. Well, that's exactly what we're telling you here with this correlations data point, right? So we're saying, hey, we found this CVE for this image, but it also exists in 15 other assets or 15 other images, excuse me, that we've uploaded into the platform. And I can click there and it's going to show me, hey, here are all the other images where we found that thing, that risk, that credential, that vulnerability, whatever it might be. And we can individually, click on these reports and go look at, those particular devices or images individually. And again, we started this video having no data in the platform and have been loading this data as the video has gone on. So, you can see that correlation just happens in real time automatically. And again, if we just really quickly go across, the different tabs in our report, not a lot of correlations here from a component standpoint. But if we look at misconfigurations, typically we're going to see quite a few there. Binaries, same thing, you may not see a ton there. But we're doing this correlations. You can always see this correlations field for literally every data point that we have in the platform. So, that's just a very quick highlight of, the scalability that we have. Again, highly recommend checking out, if you haven't already, some of our other demo videos. And thanks. We'll see you in the next one.